Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's Do Now, a suspension cable in the figure below in yellow has a length of 60 feet. If the angle theta is equal to 30 degrees, determine the height h of the bridge and the length L. So if we draw this in 2 dimensions, we have the following. So here we have the height h, this is the length L, and then we have the suspension cable in yellow, which is 60 feet. We also know that this is 30 degrees, and the question is, how do we find h and L? Well, we have to make an assumption here that this is a right angle. In this case, we can either use trigonometry or we can use the knowledge that we have about 30, 60, 90 triangles. As a matter of fact, h is equal to half of the hypotenuse in a 30, 60, 90 triangle, where 60 degrees is located over here. So therefore, h has to be 30 feet, and the length L has to be whatever the base of the triangle is times radical 3. So in this case is 30 radical 3 feet. Obviously, in engineering, you would never call it 30 times radical 3, but you want to write the approximately value in feet. So here we have a length of about 52 feet. Often, we can model a lot of these real-life problems using coordinate geometry. As a matter of fact, you can imagine that the x-axis is along the length, so we can label this x, and the y-axis goes along the height h. Or in a two-dimensional figure, we can imagine that this is the x-axis and here we have the y-axis. Why do we do this? Because there are a lot of real-life problems that can be easily solved using coordinate geometry, and then we can specify certain locations using the x and y coordinates. But let's get into detail and define coordinate geometry first before we get into all the details of coordinate geometry. According to mathopengraph.com, coordinate geometry is a system of geometry where the position of points on the plane is described using an ordered pair of numbers. As a matter of fact, recall that a plane is a flat surface that goes on forever in both directions. If we were to place a point on the plane, coordinate geometry gives us a way to describe exactly where it is by using 2 numbers. In coordinate geometry, points are placed on the coordinate plane as shown below. It has 2 scales, one running across the plane called the x-axis, and another, a right angle to it, called the y-axis. These can be thought of as similar to the column and row in an Excel spreadsheet, for example. The point where the axes cross is called the origin and is where both x and y are 0. On the x-axis, values to the right are positive and those to the left are negative. And similarly, values on the y-axis that are above the origin are positive and those that are below the origin are negative. A point's location is usually described by first taking the x-coordinate and then the y-coordinate in parentheses, as you can see in the example here. For example, if you look at this point A here, it's located 20 units away from the origin in the x direction, in the positive x direction, and 15 units above the origin in the y direction, or in the positive y direction. Now, what are the things you can do in coordinate geometry? Well, first you can determine the distance between them, between, let's say, 2 points. You can, for example, find the midpoint, slope, and equation of a line segment, determine if lines are parallel or perpendicular, find the area and perimeter of a polygon defined by the points, transform a shape by moving, rotating, and reflecting it, and also define the equations of curves, circles, and ellipses. And as a matter of fact, in this unit, these are all the things that we will learn. We will also conclude with something called analytic geometry proofs. And again, coordinate geometry is extremely useful, especially in surveying, map making, engineering, construction, and so on and so on, since the ancient Egyptians and Greeks. That is why it is very useful to learn coordinate geometry. So let's get started with the most basic object that we have learned a while ago in postulational system in our geometry class. Obviously, the first thing was a point. Okay. As a matter of fact, as you remember, these were the undefined terms. And as a matter of fact, this point can be described now in coordinate geometry as, for example, a point A having an x and y coordinate. What was the next object that we learned? Line. That was also an undefined term, a line like this. Now, how did we describe a line? Again, we could not define it, but how did we describe it? As a matter of fact, a line, we described it as follows. A set of infinitely many points connecting 2 points. For example, in this case, we have 2 points, A and B. And as a matter of fact, there's a postulate that we often have used in our proofs, which is 2 points determine a line. We can use the same concept for coordinate geometry. So let's see how we can do this. So in coordinate geometry, we have the same scenario. We have 2 points here that determine a line, okay? So these 2 points, as you can see, I can move them around, and they both have a specific coordinate point. First the x value and then the y value. Now it turns out that if I move the points around, the line itself will change slope and direction. And this is exactly what we're going to analyze next. So how do we describe the line in coordinate geometry? We were able to describe the points in terms of x and y. But what about the line itself? How do we describe that using coordinate geometry? So a line in coordinate geometry is described as follows. We actually have 3 different ways to do this. First is the standard form, which is described as ax plus by equal to c. Notice that x could be any point on the coordinate plane, and y can also be any point on the coordinate plane. Then we have a second form, which is called the slope-intercept form, y equal to mx plus b. Here the m stands for the slope, and b is the y-intercept. And then finally, we have a point-slope form, which is called y minus y1 equal to m times x minus x1. So what does the all stand for? Well, we can think of x1 and y1 to be a fixed point on the coordinate. And y and x, these are some random points in the coordinate system as well. Just to give you an idea about the point-slope form, imagine that here is your x and y axis. Okay, this is y and this is x here. And let's say you have the equation of the line in point-slope form. That means that at some point here, you know what x1 and y1 is equal to, okay? You have the coordinate, but then you also have the slope m. So that means that the other one, the xy, those are all the other points or infinitely many points here that are on the line that are defined by x comma y. But again, we will go into more detail in the next coming lessons, and I will also describe what is a slope and how do we express point-slope forms into more detail. So let's look at an example. It says here, sketch the line 2x minus 3y equal to 12 by finding the x and y intercepts and find the slope-intercept form as well. Okay, so if you look at this problem, you can see clearly that it's expressed in the first format, which is the standard form, okay? So let me rewrite the equation. So here we have 2x minus 3y equal to 12, okay? So obviously here we have the x-axis and here we have the y-axis. Okay, so how do we find the x and y intercept? So let me first write here x-intercept. Okay, so let's think about this. What has to be true for the x-intercept? If you look all along the x-axis here, what is the y value always going to be? Well, it turns out that the y value is always going to be 0. So what we can do here is substitute and say, okay, 2x minus 3 times 0 is equal to 12. Okay, so that means that here we end up with 2x equal to 12, and therefore x is equal to 6. Okay, so that gives us an x-intercept. Actually, let's call the x-intercept point A. So that means that the x-intercept is going to have an x value of 6 and a y value of 0. Okay, so the first thing we can do is to plot the point, and first we want to establish the units here. So let's say that I'm going to call this 1 unit. Let's see if that works. 1, 2, 3, 4. Okay, so we don't have enough space here. So let's erase that. And I'm going to call this 1 unit. So this becomes 2, 3, 4, 5, and 6. Okay, maybe I can write out a few more units here. So that means that the first point is located here. Okay, so I'm going to label it as A. So that's my point A. So the most important thing is when you sketch graphs, especially for your homework assignment, is to first write out the x and y axis. That's very important. And the second part is to establish the units on the grid, okay? So you want to use your graph paper and establish the units on the grid. Preferably, you want to make them the same for the x and y axis, even though you don't have to. But anyways, let me write out the units on the y-axis here. Okay, so there you go. Now, let's say we want to plot point B, and that is going to be the y-intercept. Okay, so how do we do this one? Well, what has to be true about the x value on the y-axis? Here we know that the x value is always 0 no matter what. So we're going to substitute 0 for x. So we end up with 2 times 0 minus 3y is equal to 12. So we have minus 3y or negative 3y is equal to 12. Therefore, the y value is going to be negative 4. That means point B is going to have a value or a coordinate of 0, comma, negative 4. And that is the B value, okay? So that means that point B is going to be 1, 2, 3, 4 units down on the y-axis, and that is point B, okay? So the next thing you want to do is take a ruler, okay, or a straight edge, and you can now draw the line here, okay? So also please include the arrows because we want to indicate that this is a line that goes infinitely in all directions. And once you're done, please label the line, okay? So here we have the equation 2x minus 3y is equal to 12. Okay? All right, so that's how you sketch graphs of linear equation. And then this is exactly how I want you to do it for your homework assignment, okay? So the next question says, okay, find the slope-intercept form. Okay, so let's do that now. Here initially we have 2x minus 3y is equal to 12, okay? In order to change or convert the standard form to slope-intercept form, you need to isolate the y. So the first thing you can do is subtract 2x on both sides. So here we have negative 2x plus 12. And then the next thing is divide by negative 3. So here we have 2/3 x and then minus 4, okay? So that is now the slope-intercept form. Again, what does this tell us? That 2/3 is the slope m, okay? and we will discuss more what slope is in tomorrow's lesson, okay? But anyways, the slope is 2/3. And then we have this here, which is the b value, which represents the y-intercept, okay? And you can clearly see here that the y-intercept is indeed at -4 here on the graph, okay? Okay, so this is how generally you sketch equation of linear equations. Okay, so let's look at a final example now for today's lesson. It says 3 points, A, 0, 1, B, 2, A, and 3, 7 are on a straight line. What is the value of A? Okay, so if you would have to graph this, you can think it the following. Okay, so this is y-axis. So here we have the x-axis. So this is just a rough sketch. The point A is 0, 1. Okay, so you can think of it that this is the 1. So this is 0. So here we have point A. Then we have point B. I'm not going to sketch it yet, but point C is 3, 7. So let's imagine that 3 is over here. And then we have 7 all the way up there here. Maybe I should have drawn the y-axis a little bigger. So let me actually shift this whole thing and redraw the y-axis. Okay, so I'll make it a little bigger here. There you go. So this is 2, 3, 4, 5, 6, 7. Okay, so now we have another point here, and I'm going to call it point C. Okay, so if you connect A and C and extend it in both directions, so then we have a point here at 2, A. Okay, so it's somewhere here. That is point B, which is 2, A. We want to find the value of A, and that's the goal in this example. Okay. Okay, so there are different ways to do this. Okay, you can do it graphically, but I'm going to show you how to do this algebraically. So let me shift everything over again here, so I have more space to do my annotations here. So let's use the point slope form. Okay, the third one, point slope form. Okay, as you can remember, the point slope form was y minus y1 is equal to m times x minus x1. Okay. Okay, so what we can do here now is first find the numerical value of the slope. And we can do that because what we can say, we can call this the first point, and we can use that as the second point here. So for example, we can pick 7 here, minus 1. And just to give you an idea, where does 7 and 1 come? From here, 7 and 1. These are the two y values, okay? So I'm going to let y, this point here is y, and this is y1. Okay, so that is equal to m times, so I'm going to let this point x to be equal to 3, minus, and this is x1, which is 0. So that means that 6 is equal to 3m. Therefore, m is equal to 2. Okay, so we found the slope of this, okay? Now we're going to use the slope form again, the point slope form, to figure out the value of a, okay? So now instead of using this to be xy, in the second part, I'm going to use the 2 for x and a for y, okay? So now we can write, again, from this part over here, from the point slope form, I'm going to write a minus 1 is equal to, now we know the slope, which is 2, and then the x, which is 2, minus, and here we have x1 equal to 0, okay? So that means that a minus 1 equals to 4, therefore a has to be equal to 5, okay? And that is the final answer. So that's how you can use the point slope form. Now, the next question is always, does this make sense? And let's look at this. If this is 2, and again, this is just a rough drawing, then this value should be about 5, right? So 1, 2, 3, 4. Okay, so here we have 4. But again, keep in mind, it's not really drawn to scale. Maybe my point should be a little bit more here. Okay, there you go. Now this makes a little bit more sense. Okay, it makes sense, right? 1, 2, 3, 4, and 5. Okay. Again, this is just a rough sketch, but that's why it's very important to draw everything you have in the most accurate way as possible. Okay. Okay, so this was basically the introduction for today's lesson. Okay, we introduced coordinate geometry. We discussed the three forms: the standard form, the slope-intercept form, and the point-slope form. Okay. So other than that, I want you to please do the following homework, okay, from the Green Book, page 450, numbers 2, 6, 16, 22, 27, 32, 36, and 48. These are 8 problems only. Please show all your work. Use graph paper to sketch your drawings, okay? Everything nice and neat. And use a ruler or straight edge. Other than that, thank you again for watching this, and have a great day.